Hello everyone, this is Mr. O'Leary with a video on chemical equilibrium. Chemical equilibrium is a state of balance in which the rates of opposing chemical reactions are exactly equal. Remember, just focus on rates, the rates of chemical reaction, the rates of the forward and reverse reactions. Most reactions are reversible, and if we look here, we see a double arrow. It's noted by a double arrow. So if I have 2NO2 in a gaseous state, it will give me N2O4 in a gaseous state. So what we look at here is this is a double arrow, and it means it will go forward and it will go reverse. So if I put a bunch of reactants in, it will flow towards the products. If I put a bunch of products in, no reactants, it will flow towards the reactants. And depending on what the KEQ or the equilibrium constant is, that will tell you how much reactants or products are there. Most reactions do not go to completion, do not go all products and go to completion. And what we do is we write this out by KEQ, the chemical equilibrium. The equilibrium constant is just the concentration of the products divided by the concentration of the reactants. And if you look up here, these aren't zeros, this is just showing it's a placeholder. It goes by the coefficient. So if we have N2O4, the coefficient is 1, we would take that and make that coefficient 1, which we all know from algebra you don't need to have 1x, so you don't need to have a 1 there. And the reactants, the coefficient, it's 2, we would have to write a 2 here. So in this instance, what we can do is if I didn't know the chemical equilibrium, but I tested the concentration of the products and tested the concentration of the reactants at equilibrium, you could tell me what the KEQ is. If I had the KEQ and the products, you could tell me the concentration of the reactants. If I had the KEQ and the reactants, you could tell me the products. It's just simple mathematics, simple algebra. These reactions, it could take seconds or it could take years for this equilibrium to happen. But once it's reached, the forward and reverse rates of reaction are equal. So if we look, it's just quick notes. At equilibrium, the forward and reverse rates are equal. At equilibrium, the concentrations of products and reactants are not changing. That does not mean that they are equal. It means they are not changing. And what we do is we write this by the chemical equilibrium expression, and we have here KEQ is equal to the concentration of the products over the concentration of the reactants, and the coefficients are what we raise it to. So, and this is called the equilibrium expression. So if we were to look and we were to write the expression for this one, we would simply write KEQ is equal to the concentration of the products, which is N2O4, over the reactants, which is NO2. But the N2O4 doesn't have has a coefficient of 1, so it's raised to 1, or we just don't write it. And NO2. NO2 has a 2 coefficient, so we'd raise it to the 2 power. So if I gave you those concentrations, you could tell me the other. What we're going to be doing today, you're going to be doing a worksheet that has HI, the HI worksheet. It's quick, it's easy. You should pick it up quickly. So we have H2 plus I2 will give me 2HI, and this is a double arrow, meaning it can go forward or backwards. So again, if we were to write a KEQ expression for this equilibrium expression, we would write the concentration of the products divided by the concentration of the reactants, and then we would raise them to the power of the coefficients. So we'd have the concentration of the products, which is HI, and we have a coefficient of 2, so we'd raise it by 2, over the concentration of the reactants, so it would be H2 and I2. And 2 things to note here. There are no coefficients, so I'm not going to raise them to the coefficients because I raise them to 1, which is fine. You can do that, but you all know what that is. But also, you notice how it's H plus I, H2 plus I2. In the equilibrium expression, you would multiply them. So that's our lesson for today. You should be able to figure this out pretty easily, I think. If you have any questions, just ask me, and I will be happy to help. And this is, we're only going to be talking about the state of matter matters, but we're only going to be talking about gases because we don't have a lot of time left. If you have any questions, please email me. Thank you, and stay safe.